Welcome. My name is Bob Sullivan. I'm the CTO of Engineered Packaging. We're a division of Curtiss-Wright Controls Electronic Systems. What I'll be talking to you about today is CoolWall. It's a breakthrough new thermal technology for thermal management of rugged electronic packaging. This is a new patent-pending technology developed by Curtiss-Wright Controls that can provide significant benefits for rugged electronic packaging in terms of weight reduction and improved thermal management. Historically, the electronic enclosures that have used either steel or aluminum for construction materials, and that's because of their relatively low cost and wide availability. Steel is quite a bit heavier, and its thermal conductivity is not as good as aluminum, so it's typically used in commercial applications, whereas aluminum is typically used in ruggedized applications such as these chassis you see here. Because of the limits of aluminum in terms of its thermal conductivity, thermal performance, other techniques are often used, such as copper for heat spreading, but copper weighs 3 times as much as aluminum, or the use of heat pipes, which have positional issues and also complexity in the chassis. Today, the embedded computing market is increasing its use of technologies such as multi-core processors and high-speed signal fabrics in a lot of applications, particularly signal processing applications and multi-processing applications, which are becoming increasingly important in some segments of the rugged embedded computing market. And as a result, some new backplane architectures such as VPX have sprung up to take advantage of some of these higher performance chip-based technologies. But a side effect of that is that a lot of these products also come along with quite a bit higher thermal dissipation or heat that has to be removed somehow in the packaging. What we have done at Curtiss-Wright is developed this CoolWall technology, which, as I said earlier, is a breakthrough that delivers 2.4 times the thermal conductivity of aluminum at 10% less weight. And the initial product that we've introduced is this chassis here, which is our SFF6, which is a small form factor base plate conduction cooled chassis. And this chassis allows us to cool 67 watt per slot 3U payload, whereas in this geometry we would be able to cool less than half that if we built it out of aluminum. Preliminary testing of CoolWall in our new SFF6 chassis that you see here has shown a 2.4 times improvement in thermal conductivity or temperature rise across the sidewall versus construction of the same geometry in aluminum. So, for example, this chassis can cool 67 watts per slot, where we would be limited to about 30 watts per slot in a traditional aluminum construction. And what that does for us in this particular application is allows us to cool a hotter payload. However, the same CoolWall technology can be optimized in a different way in order to reduce weight. So even while we increased the thermal performance by more than a factor of 2, we reduced the weight by 10% versus what it would have been in its aluminum counterpart. Optimized a different way, this chassis could be significantly reduced in weight to go after lower power payloads that were in the 20 or 30 watt range, for instance.